Hi everyone, this is Aaron, and today we're going to talk about significance test with average scoring in golf. Alex is a PGA Tour professional golfer. A news reporter claims that Alex is just an average golfer on the PGA Tour. However, Alex thinks that he's better than the average score on the PGA Tour, which is 71.391. So he gathered a random sample of 20 scores that he shot in tournaments, and the data are the following. Can Alex claim that he is really better than the tour average? Give statistical evidence to support your answer. So here we're going to use a system that is called phantoms. P stands for parameter, and in this case, we're going to use one sample mean t-test of Alex's average golf score in tournaments because the standard deviation of the population is unknown. H stands for hypothesis, where the null hypothesis is mu is equal to 71.391. To explain it in context, it means Alex's average score in tournaments is 71.391. And the alternative hypothesis is that mu is less than 71.391. And it means Alex's average score in tournaments is better than the tour average, which is 71.391. In golf, less the score, better the player has performed. Just a side note. A stands for assumptions. In this case, we're going to check three conditions. The first one is random. Random sample as stated in the problem. So we're okay to proceed. Normal condition. Since the sample size is less than 30, check the distribution. And the box plot is on the right side. As we can see, there's no outliers, and it is approximately symmetric and single peak. Normal conditions met because all three elements are satisfied. Assumption continued. Independent condition. Since this is a sample, not an experiment, 10% rule needs to be checked. 10 times small n is less than big N. So 10 times 55, which is the sample size, is less than n. And we get n is greater than 550. So the population has to be greater than 550 in order to proceed. Independent condition is met because the samples are randomly selected, so each observation is independent of each other. So N stands for name the test and formula. In this case, we're going to use one sample t-test because the standard deviation of the population is unknown. And we're going to choose 0.05 as our significance value, or alpha value. And the formula we're going to use is T is equal to x bar minus mu naught divided by the standard deviation of the sample over the square root of the sample size. T stands for test statistic calculation. And here we have our formula, and we substitute the values in there, and we get T is equal to negative 2.871. O stands for obtaining p-value. In the previous slide, we already got that T is equal to negative 2.871. And with this T value, we can get the area to be 0.00489. And since it's one-sided hypothesis test, we can know that the p-value is also 0.00489. And here's a graph that shows the area that's shaded, which is the p-value. And if this is a two-sided test, we would have doubled the area in order to get the value, the significance value. M stands for making the decision. P-value is 0.00489, and our alpha value chosen was 0.05. And here we get that our p-value is smaller than our alpha value, which means that the result is statistically significant, which means we can reject the null hypothesis that Alex's average score is 71.391. S stands for state the conclusion. The first part is interpreting p-value. Assuming that H naught is true, which is Alex's average score is 71.391, the probability of getting a value as extreme as 70.05 is 0.489%. Because the p-value is smaller than the alpha value, there is enough evidence to reject H naught. Alex's average score is 71.391 and accept the alternative hypothesis, where Alex's average score is better than the PGA Tour average.